Okay. All right. So theorem 7.10 is pretty much the same. All right. Where it's saying the ratio of corresponding medians of similar triangles is equal to the scale factor. Okay. So let's go ahead and talk about what a median is. So what a median is it's connecting a vertex with the midpoint of the opposite side. All right. So what I'm going to do is I'm going to eyeball the midpoint of that bottom base. Okay. And to show that it's a midpoint, I have to state that those two segments are congruent. And then just connect that, all right, with the top vertex. So that's a median. Okay. So in example 3, it says, what can you conclude knowing that triangle ABC is similar to triangle DEF? Okay. Now, these are medians, so let's go ahead and mark that this side is congruent to this side, and then this side is congruent to this side. So once again, let's talk about the markings. Why couldn't I say that all 4 of those are congruent? Well, for corresponding sides, the sides don't have to be congruent. They have to be similar, which means that they are going to have different side lengths, okay? So let's find our scale factor. All right, so I'm going to say that AB is to DE. All right, and then we have to select our medians. So then AG is to DH. Okay. All right, now our next theorem is different. All right, so this is the only one that's kind of different than the other ones. So this one is the triangle angle bisector theorem. So the difference is on this one is that we're actually only looking at one triangle, okay? So the 3 examples before, we had 2 triangles that we were comparing the medians, the altitudes, and the angle bisectors, okay? So what the triangle angle bisector theorem says is that an angle bisector of a triangle separates the opposite side into segments that are proportional to the lengths of the other 2 sides, okay? So what I want to do is actually just use this picture down here, okay? So I'm going to first tell you guys that BD is an angle bisector. So I'm going to say this angle is congruent to this angle. And what this theorem is saying is that BD is splitting up, all right, this opposite side into segments that are proportional to the other 2 sides, okay? So this is what I'm going to do. I'm going to start off with AB right here. Okay. And then I'm going to connect that, all right, to one of the segments of the opposite side. All right. Now, which segment am I going to connect it to? I'm going to connect it to the segment that is adjacent, all right, to that side length. So I'm going to have AB is to AD, which is equal to, all right. Then I'm going to do the other side length. All right, so BC. And then I'm going to write that as a ratio connected to the other segment within that third side that's adjacent to it, which is CD. Okay. Now, you could obviously have switched this around using the interchange of means property, all right, which I could say instead like AB is to BC. I'm sorry, to BC. As AD is to CD. All right, that would work as well because I'm still matching up, all right, AB with the adjacent side, BC with the adjacent side, okay? All right, so let's go ahead and do some practice problems for this, okay? This is for all 4 of these different theorems. So in example 4, it says find the value of x if triangle ABC is similar to triangle DFG. So let's take a look at our picture. Which special segment do I have in there? Okay, well, what I have in there is a bunch of angle bisectors, okay? So let's go ahead and notice that I have AB and DF, all right? Those sides correspond with one another, okay? So that's going to be my scale factor. So my scale factor is 15 over 12, which reduces into 5/4. All right, so to set up my proportion, I'm going to do 5 over 4 is equal to, all right? And I started with triangle ABC, so my angle bisector is AP, and I'm going to match it up with a 5. And then my angle bisector of triangle DFG is 8, so I'm going to match it up with a 4. So cross multiplying, I'm going to get 4x is equal to 40, and then dividing that out, I get x is equal to 10. All All right, let's try the next one. Okay, so if we look at our special segments, these are going to be altitudes because they're segments, they're perpendicular segments connecting a vertex with the opposite side, okay? So let's take a look at what we're given. Our side lengths that we have are km and yx, okay? And those are corresponding sides, so that works. So that's our scale factor. So my scale factor is 20 over 15. All right, now if you simplify that, you're going to get 4/3. All right, so my scale factor is 4/3. So setting up my proportion, 4/3 is equal to, and I started with triangle KML, so my altitude has a length of 16. And then for YQ, it has the X. All right, so cross multiplying, we're going to get 4X is equal to 48, which means that X is equal to 12. All right, next one. So on example 6, once again, it says to find the value of X. And let's see what we are given. All right, we are given medians, okay? So on this one, it's going to be a little bit different. All right, I am going to set up my medians to be my scale factor, all right? And we know that they're proportional, so that's fine. So we're going to do, on this one, all right, 9 over 13.5 equals, all right, matching up the 3 with the 9 because they're in the same triangle, and then the x with the 13.5. If we cross multiply that and solve it, we're going to get x is equal to 4.5. All right. Next one. All right, so this one is telling us that AD is an angle bisector. So this is an example of the last theorem, all right, where we're looking at one triangle. So what I want to talk about, though, is what's going to be the expression for this segment right here, because what we're comparing are the segments that that third side is split up into, okay? So I know that BD has a length of X. I don't know what the length of DC is, right? So I have to write it as an expression. So what I'm going to do, all right, is just kind of put a number in there just to kind of see what would happen. So what if I put a 6 in for this X, all right? What would I do to get the length of DC? Well, I would take 14 and I would subtract 6 from it, right? Same idea is I don't know what that X is, so my expression for DC is 14 minus X, okay? So now let's go ahead and set up our scale factor. All right, so our scale factor is going to be comparing our two side lengths. So I'm going to do 10 is to 15, okay, which reduces into 2/3. All right, so I'm going to have 2/3 as my scale factor, and now I need to set up the corresponding segments with it. All right, so because I started with the 10, I need the segment that's adjacent to it, which is the X. And then for the 3, all right, that's going to be the 15, which means that 14 minus X is the segment that's adjacent to that. So now we're going to cross multiply. So make sure that when you're cross multiplying this 2 and this 14 minus X, you're distributing it to the 14 and to the X. So this is going to become 28 minus 2X is equal to 3X. I'm going to add the 2X over. And for a lot of these examples, you are going to get decimals, okay? So I'm going to get 28 is equal to 5X. And then dividing that out, I'm going to get X is equal to 5.6. Okay? All right, I'm going to pause there, and we have a couple examples left.